In this video, we're going to take a good hard look at just a portion of the graph of the sine function to try to understand how the shape of the sine function comes about. So we're going to look at the function f of t equals sine of t, and we're going to concentrate just on the interval t between 0 and pi over 2. So remember, t is an angle, so it's going to be the angle 0 and the angle pi over 2. Pi over 2 is also 90 degrees. So we're going to study whether f is an increasing or decreasing function on the interval. And we're going to see how the average rate of change alters over the course of that interval. All right, so first of all, I want to remind you that we're looking at y equals sine of t, and we're going to be looking at a couple different pictures on Desmos. So I'm going to show you that right now. Okay, so first of all, we're going to understand the sine function through the unit circle. When we talk about understanding it through the unit circle, we first got to talk about what our angles are. So anyway, I've drawn a unit circle here, and I'm going to show you how the angles work. So here is a line that's going to determine our angles, and I should start that angle, all the way down here at 0. So we can see that point on the unit circle going between 0 and pi over 2. And just to show you where that point is, I'm going to make it blue over there on the end so you can see that point on the unit circle. So we're interested in the y-coordinate on the unit circle. So if we're at a given angle, right, we want to see what the y-coordinate is. Well, first of all, I want to show you where the positive x-axis, so it's easier to see that angle. But I also want to be able to show you where that y-coordinate is. And that y-coordinate is going to be right across from that blue dot. So I'm going to draw that. It's going to be right here. There's that purple line, and the purple line goes to the y-axis, and where it hits the y-axis, that's my y-coordinate. So I'm going to move this around so you can see the angle between the 2 points, between the 2 lines, the positive x-axis, the line created by that point on the unit circle, and the y-coordinate that you're following up the y-axis with that purple line, right? And so you can see the y-coordinates going up and down, while the angle goes up and down. All right. Now, the other way we can understand this function is literally as the graph of the function, where the input, you can see down here with this pointer here, the input is t, and the output is, I couldn't fit sine on here, so that s of t is going to be sine of t. Right? And what we're going to do is we're going to go back and forth between the unit circle and this graph of the sine function to understand how the graph is going to work. So I'm going to go back here to the unit circle and then go back to the next point I'm going to make. So the first place I'm going to look on this graph y equals sine of t is I'm going to look at the endpoints. Remember, we're looking between t equals 0 and t equals pi over 2. So I want to see what happens at t equals 0. You get sine of 0, which gives you a sine of t equals 0, so your y is equal to 0. And if you put in t equals pi over 2, sine of pi over 2 equals 1, so that gives us y is equal to 1. So if we're looking on the unit circle, if we're looking at t equals 0, that's way down here, you can see our y is equal to 0. And if we're looking at t equals pi over 2, our y goes all the way up to 1. So now if I'm plotting this on our graph of our function, you can see over here, I have t equals 0, y equals 0, and then I have t equals pi over 2, y is equal to 1. And so I'm going to go ahead and plot those. Well, actually, first of all, I'm going to show you where x equals pi over 2 is. That's where our graph is going to end. If I plot 0, 0, and pi over 2, 1, these are the 2 points I get. These 2 black dots here, black dot here, black dot here. And I'm going to go ahead and label them as well so you can see them on the graph. Next, we're going to look at the outputs of the function. And in particular, I want to know whether the outputs of the function are negative, positive, 0, what kind of values that do we get. All right, so now if I'm looking at the y values between 0 and pi over 2, I'm going to start at 0 again. Notice that my y values, the lowest I'm going to get down here is 0 for y. I can't get any further down than y equals 0. And as my t increases, notice that my y continues to be positive. It's going to go y from 0 all the way up to 1, But again, anytime I'm between 0 and pi over 2 for my t values, my y values will never be negative. So I'm always going to get non-negative values for y. Next, I want to ask, is the function increasing, is it decreasing, or both? Well, again, we're going to look at the y-coordinate as we change our coordinate of t. So notice we start at 0, and notice as my t gets bigger, my y continually gets bigger as well. You can see the y getting bigger and bigger and bigger each time as t getting bigger, never going back down, which tells us that our function is increasing. So now if I want to look at my actual graph, remember my graph is going to start down here at 0, 0. It's going to end out here at pi over 2, 1, and I'm going to have an increasing function. Well, that doesn't necessarily tell me what the shape of my graph is going to be. There are actually kind of 3 different choices I can have. One is I can just have a straight line going straight from my point on the left to my point on the right. Right? It could be a linear function, a line. The other possibility, or one of the other possibilities, is my function can start being very steep, having a high average rate of change, and end up having a lower average rate of change. Notice right down here, my average rate of change is very steep, where then as it gets less and less steep as time goes on, which tells us that our average rate of change of our function is getting smaller and smaller. And the third possibility is that process can go in reverse. In other words, I can start with a very shallow graph, right, a very shallow slope, and then my average rate of change gets bigger and bigger as time goes on. And the question is, how can I tell what's going on there with by using the unit circle? Let's go back and check. Well, first of all, I got to have some way of sort of visualizing my average rate of change. And remember, my average rate of change is between 2 different angles. So what I'm going to do is I'm going to have an angle that's kind of nearby. And also an angle where that angle doesn't change in between the two, the change in angles, the difference in the angles doesn't change at all. So if you look at between t equals 0, look at the 2 angles. Notice how the difference between those 2 angles remains exactly that same. The space between those 2 angles is exactly equal no matter how I change them. Whether I go very high or very low. So what that's going to do is that's going to give me my change in my input is always going to be the same. When I subtract my inputs, I'm always going to get the same value, which tells me that if I look at the difference between my y values, that will tell me a little bit more about how my those changes are going as well. So what I'm going to do is I'm going to show you those horizontal lines for both of those angles, right? So this is going to be kind of crazy. Start at 0 down here. And notice that right here, my output, my sine of t here is 0, and my sine of t here is approximately 0.2. So a pretty big difference between those 2 y values. And notice what happens to the difference between those y values as I increase my t. So they're both getting bigger. Both my y values are getting bigger. But notice how they're getting squeezed closer and closer together. And what that's telling me is even though the difference between my inputs is exactly the same, the difference between my outputs is getting much, much smaller, which means my average rate of change itself is getting much, much smaller. So way down here, I have a big difference in my outputs, in my sine of t's. And up here, a very small one. So that tells me my average rate of change starts out big and gets smaller. How's that going to look in the graphs? Well, let's look. If I have a line, there's no change in my average rate of change. My average rate of change is the same no matter where you are. That's exactly what made it a line, a linear function, right? So it's not a linear function. If I look this one, my average rate of change starts out very small and gets very big. That's the opposite of what was happening. So what's actually happening in this graph is we get an increasing function, as I mentioned, where the average rate of change gets smaller as my t gets bigger. So that's how we were able to use our analysis of the unit circle to figure out what the graph of the function was going to look like. So this should help give you a head start on the activities that we're going to look at for this particular part of our section. You want to look at the file called Understanding the Graph of Sine Function, and that's on the PDF included with this video.